Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time, we talked about using the string object, and this time we are going to cover organizing code. Right? What that means. So, without further ado, let's get into the objectives. In this video, we're going to define some functions, call them, create some anonymous functions, and decorators. We're going to define some classes and instantiate some of them. Use inheritance for pre-existing classes. Then organize our code with modules and packages. So let's get into it. We don't want a 500,000 line Python program. We organize our code in various ways, and probably the lowest level is functions. So you take a group of related code, organize them into a function, and then in the main part of your program you just have a one-line call to that function. Now that function may be 1,000 lines, but you can use it in multiple places. And even if you only use it in one place in your program, it's organizing it so you just see in the main part of your program the single line to call it. So the lowest level, we can define functions to organize our code. You can define functions to provide functionality by using the def keyword, DEF. And then you put the function name, your parentheses, and a colon. We know about the colon beginning blocks from our previous work with if statements and for loops. This is similar. We're going to see this in a minute. Then you put any input parameters and arguments inside the parentheses. And the first line of your function could be a string, just a string, and that will be what is called the doc string. We're going to look at that later. Then the function body is indented after the colon, just like other for suite, while loop. And then at the end you have a return statement. Or actually anywhere in the function you can have a return statement to exit the function. And if you don't have a return statement, it will automatically return none to the caller. None is a special Python type, special object. So here we see a function defined. If the function is called printMe, and it accepts a single argument, and then it prints it, and then returns. So we have the DEF, the name of the function, our parentheses, and inside we have our arguments. It could be a this is not a type, this is a string. We can call this anything we want. Name. We can give it more arguments. Age. As many as we want. And we don't want to skip to the end, do we? Just yet, do we? Okay, so how do we call a function? We define a function, and once the basic structure is finalized, you can execute it by calling it from another function, or directly from the Python prompt or the body of our code. we can call the printme function by using the name and the parentheses. And it does accept one argument, so let's have a look really quick. And can we, let's see if we can put this in our interpreter. Let us run Python. Let's type this in. So now we can see printme is a function. And if we try to call it, it says, oh, we're missing one required positional argument. So it's looking for a parameter called string. So let's try it again, and this time we'll give it an integer. So it doesn't matter if it's not a string. The string is not a type, it's just a name. So there we can see that it prints the string passed to the function. It printed that. And then it printed our string that we passed it. Right. Maybe we want to try calling it. Let's see if this actually works. Well, that looked like it worked. Let's pass it with this second argument. Yep, looks like it's all working. So creating anonymous functions. Functions are called anonymous if they are defined using the lambda keyword and not with the normal def keyword. They can take any number of arguments, but the function body can only contain a single expression of which the evaluated value is returned. Okay, so we looked at this before. We used lambda functions in expressions, chapter 5. Decorators. Altering functionality with decorators. A decorator is a function that takes another function and extends its behavior without implicitly modifying the code. So let's talk about some aspects of a function. First, we can assign multiple names to the same function. So here's a definition of a function. Let's have a look at that. Yep. So sucks is a function, and if we call it, we pass 10, it returns 11. Now we could say x equals suck, and we could say x sub 10, and x sub 100, x sub 1.2. Looks like it's working. Next, a function can be placed inside another function. So that's called a nested function. One function inside of another function. Here's an example. Here is our f function. We have a function called f. So we use def. There are no parameters inside the parentheses. And here is, after the colon, we begin the body of the function. Here's the body of the function. First thing it does, it defines another function inside of itself. So that's g. So at the end of the function f, we are printing and calling g at the very end. So the output looks like this. So first, this is our function definition. So our main line begins here. And all we do is we call f. So first thing f should do is it should go here. First thing f actually does is it defines g. But the first thing we'll see is it's going to print, this is the function f. Then it will say, I'm now calling g. And then it will actually call g. And it says, hi, it's me, g. Thanks for calling. Okay, thirdly, a function can be passed as an argument to another function. So our main line here is we are calling f, but we have a new definition for f. So we're going to call it, and we're going to pass it g. And now g is actually a function. So in Python, functions are first-class objects, which means you could pass them around just like variables. Now notice we passed g. We didn't call g. We didn't do this. We didn't do this deal. We're not calling g and passing in the result. We're actually passing the reference to g to f. So f will receive a parameter called function, func. It'll say, hi, it's me, f. I'm going to call func now. And then it will actually call func, which is the function it received. Whatever function you passed it, it's going to assume it's a function, and it's going to call it. So it calls g and says, hi, it's me, g. Thanks for calling me. Next, functions can return references to function objects. Okay. We're getting closer to deal with our decorators here. So now f is defined as such. It defines g inside. And now f will return g. So when you call f, what you're going to get back is a reference to another function. Here's the function g. So here is our main line. We are going to call f, and we're going to store the value in nf1. And nf1 is going to have the reference to a function g. So we can call it. We're assuming that we're getting back a reference here. So we're going to call it. So this is calling the same thing as calling g. And it should say, I am inside function g. So now we can use all of these concepts to create a decorator function. All right. Now here is our decorator function. Now if you return a function, just like we saw the last one returning g, we're returning function wrapper, which is defined here. There's our function wrapper. Now so when we call our decorator, we're going to get back this function reference. We're not calling it here. There's no parentheses on the end here. So we're not calling it. Our decorator merely returns the reference to our function wrapper. So if we have a function reference returned from a function, we can use that function this one, our decorator. We can use it as a decorator. What we do is we precede it with an @ sign, and that becomes our decorator. So when we call foo, here's our function foo, right, which is decorated by our decorator function. So when we call foo, it's going to expect a value, so we'll pass it 42. So this should say, hi, foo called with, or whatever it's called with 42. So where did this come from? Decorating the function foo. Now, function foo is decorated by our decorator, and the decorator returns this wrapper function, and the wrapper function could expects this, which it gets as 42, and we could do something with that. So let's try it. All right, let's see what we get. All right, our decorator is a function. All right, now let's define foo, and we define it as decorated. So now let's call foo with, let's try 42. Decorating foo. Now, if we want to change our decorator at all, we can, let's say we can do something, decorating foo, we can do something with x. Let's define, when we print decorating foo, let's print our x that we got back, right? Let's print it out. So let's call foo 42. We have to redefine foo. So we changed our decorator function, but we didn't redefine foo with this new object, so that's why I had to redefine our decorator. We had to redecorate foo. So now it says decorating foo 42. So we can actually do something with 42. If we wanted to, let's say we wanted to increase it by 1. Right? So we could say our function wrapper receives 42. It says decorating 42, and then it will call our function with 43. Let's see what happens. So we're decorating 42, but now we're pretending that foo got called with 43. Right? We could say 1. We could say negative 1, 2, 3. So we can use decorators to change our values. So like we said, it changes the code, it changes the function without actually changing the code. But the actual function behavior is changed. So a class is a user-defined prototype for an object that defines a set of attributes that characterize any object of the class. So we use the word, this is a keyword class, we give it a class name and our colon, which starts a body. The first line, just like functions, can be a docstring. And then we begin our class suite, our body. So let's define a simple class employee. We can call this anything we want. There's our docstring. So let's have a look. Can we type this in? Oh, it probably won't like it because too many spaces. So let me just take the spaces out. It makes it easier to cut and paste. So now, class is a, that's not right. Class is a, employee is a class. All right, employee is a class. So now we can say we can look at the variable count and see that it's a class variable. It's defined directly on the class itself. That's called a class variable. So all instantiations, all objects, all employee objects share this single count. And then we see the init method, the special constructor that accepts 2 parameters, name and salary. This is how Python gets a self-reference. You can call it anything you want, but everybody uses the word self here. And Python will automatically load this parameter with an argument to point to itself. So let's create a couple of employees and see what we get. So this is employee is a class, but now emp1 is an object, an instantiated object from the employee class. All right, now if we type in employee.count, we have 1 employee. So now we have 2 employees. All right. And so we access our attributes and methods with the dot notation. You can, emp1 dot display employee. Right. In object-oriented programming, inheritance is a way to reuse code from existing classes. You can make a derived class, a subtype, a subclass. So a subclass inherits all the attributes of a parent class. And we can also create new attributes and methods inside of the subclass. And we can even override some of the parents' classes. So let's see that in action. All right, if we have a parent class and we have a child class, then we can inherit from the parent class. And we have our parent class defined. And we have our child class can also be defined. All right, so parent, child. Now, if we call we can say C equals child. All right, so it says we called the child constructor. Now we have init here. Dunder init, as it's called, is overriding dunder init from the parent. Oh, as you can see, we define the child class with the keyword class, the name child, the name, whatever we give it, child, and then the base classes. So we're inheriting from parent. So we have all of these attributes inside of here. So, but we're overriding this method from the parent. So you can see it doesn't say calling parent constructor, it just says calling child constructor because we overrode it here. So let's see if we can print off our parent adder. Oh yeah, it's 100. All right. And we can call child method, calling child method. We can call, now can we access parent methods? Okay, calling parent method. Now let's set our parent attribute to 200. All right. And now let's get attribute. So now the parent attribute is 200. Huh. So we changed it in the child class. How else can we organize our code? We can use functions, we can use functions inside of classes, and now we can put classes inside of modules. A module is a file consisting of Python code. It's a file. Module is a file. It allows you to logically organize your code by grouping related code into a single file. So a function contains code, a class contains functions, which are called methods, and a module contains classes. So this makes it easier to understand and use. An imported module is a Python object which has attributes you can bind and reference. A module can define functions, classes, and variables. A module can also include runnable code. To be careful with that. You can use Python source file as a module by executing an import statement in another Python source code, as long as the file we're importing has an init.py file next to it. So how we import it, we say import and then give it the module name. We can give it as many as we want. So a search path is used in its search to find the modules. We're going to talk about that. We're going to talk about this directly. So locating the search path. When you import a module, the Python interpreter searches for the module in the following sequence. First in sys.modules. If you already imported, it'll be in sys.modules. Otherwise, it'll look for its own built-in modules. And if not, it'll look for a module in the directory of the init script, or the current directory if you're in the interpreter like we are. If not found anywhere of these three, then the fourth option is to look at the Python path environment variable. That should be a string to tell it where to look. And if all else fails, it will be the installation dependent default. Like on Linux, it'll be user local bin, or it will be different depending on your operating system. Using packages to group modules together. Now, code sits in functions. Functions sit in classes. Classes sit in modules, and modules sit in packages. So a package is a hierarchical directory structure that defines a Python environment consisting of modules and subpackages. So modules are files, and subpackages are just subdirectories. So consider this directory structure. Here's a directory called phone. And inside of it, there's 4 files. So we have, in the phone package, we have 4 modules. Init.py is a special module that gets imported whenever we import phone. It's automatically imported. And we just reference it with the phone namespace. So we can define functions inside of our modules. So let's say inside of the G3 module, we define a function called G3, and so on. All right, let's look at that. Now, to make all of your functions available when you import phone, we're going to want to import them automatically. We can. You don't have to. We can automatically import them from inside of our init.py file. So let's look at, we have our phone. All right, so PyCache is our cache. Once we run things, it creates a PYC file, and then it only has to. It's a compiled Python file. Once we compile them, it puts it in PyCache, and then we don't have to look at them again. So let's, the infamous RM minus RF. You got to be very careful, boys and girls, about using this. So let's just get rid of it. All right, so let's run Python. Now when we say import phone, we can look at phone, and now we have G3 is automatically imported, ISDN and POTS is automatically imported for us. So now we can run, for example, phone, and they're all imported to this phone namespace, phone.g3 function. And if we want to call it, well, we just called it. As we saw before, it didn't do anything. It just runs pass. But now we have our functions automatically imported into our phone namespace. So phone is a module, but we consider it, since it's a directory, we call it a package. So the assignment is to write a program that uses a practical use of the decorator function. All right. So that is it, boys and girls. We just talked about organizing our code. And next time we're going to talk about a longer topic: arrays, collections, and dictionaries. All right. So that will be for next time. All right, that's it. Thank you.